Alright guys, let's check out chain rule part 2. So we're going to continue our work with the chain rule today. The only difference is that we're going to do the chain rule in tandem with the product and or quotient rule. We'll also show you how you can do like a double chain rule. So basically it's kind of like taking the stuff we've already learned and smashing it all together into a bigger problem. So it's a little bit overwhelming because there's so many, like, it gets kind of big and wild looking, you'll see what I mean, but it's not that bad. It's really just the same stuff we've been doing. So let's go ahead and jump in. So let's take a look at this problem here. Now, we learned a lot of rules. We've learned the product rule, we've learned the quotient rule, we've learned the chain rule. We know the power rule, the constant multiple rule. We learned a lot. Now let's go ahead and take a look at this. What rules do you see can be applied here? Well, I hope you see most obviously the product rule. Okay, that to me that stands out really obvious. Like right here and right here we have A and B, right? So Y prime is going to be the old A, B prime, product rule, right? But that's not all there is to this problem, and you'll see why in just a second. So let's go ahead and get started. So we have A prime, so what's the derivative of this? Well, that would be 4, nice and simple. Then we're just going to put B there. B is 2x to the third plus 1 to the negative 3 power. Okay, on the next one, we're going to put A in. So A is just going to be 4x plus 3. Now B prime, something special is going to happen here. How do you take the derivative of that? Well, that is a chain rule. So as you can see, we have a product rule is what we're doing, but part of the product rule is now a chain rule. We have the inside function, 2x cubed plus 1, in parentheses, right? And then we have the outside function, which is a quantity to the negative third power. So to do the derivative of B, we actually need to apply the chain rule. So let's do the derivative of the outside first. I'm going to put the power to the front. I'm going to take 1 off of the power, so now it's even less, negative 4. And we don't change the inside, right? So the inside is going to stay as 2x cubed plus 1. And now we multiply that by the derivative of the inside. So the derivative of the inside is, power rule here is 6x squared. And then we have the 1, the derivative of that is 0, so we don't even need to bother writing it. Okay. Let's take a look. See here. So that's the big idea there. So if you can get this far, you've done a lot of the work already. Now, I want to show you what the answer will probably look like, though, on a multiple choice test. Because it probably won't look like this. They'll probably write it a little bit differently. One thing's really obvious, I think, is that for this half over here, they're going to multiply the 6x squared with the negative 3, and they're going to put it in the front instead. So what that's going to look like then is the following. I think I'll just rewrite the whole thing, actually, if you don't mind. So we have 4, 2x cubed plus 1 to the negative 3. And then, like we said, negative 3 times 6x squared is going to be negative 18x squared. Now, since I'm adding a negative, well, I'll do that in a minute. Let's just finish the problem. So we have negative 18x squared, that's those two, and then we still have the 2 parentheses sets left. So we have a 4x plus 3, and we still have the 2x cubed plus 1 being raised to the negative 4th power. Now, right here we have adding a negative, right? Well, there's no sense in being redundant here. We can just, when you add a negative, that's the same thing as subtraction. So this is probably what it will look like on your test as the final answer. Okay? So in other words, clean it up as much as you can. I have seen certain exams factor out common factors, like for instance this 2x plus 1 to the negative 3 power. You can divide that out. I don't think I'm going to bother doing that, though. I think I'll just leave it like this for now. But sometimes if you have a common factor here, they'll factor it out. The reason why I'm not going to do it is because the negatives are there. I might show you an example of it later today, but with negatives, I don't think they would do that. It wouldn't work out well. So anyway, there you go. So I gave you a few extra details, but what I really wanted you guys to notice is this, that in the beginning, it's very obvious that you're looking at a product rule. You have two functions being multiplied. But what's not quite as obvious is that in the process of doing that product rule, one of those pieces is going to have the chain rule done to it in the process. So as you guys can see, it's a chain rule with the product rule. Okay. I'm going to not do this one yet. I want you guys to try one. So let's go ahead and have you guys do a chain rule with a product rule. Go ahead and try that one and pause the video. When you unpause it, you'll see the solution. Okay, so here's what I get. The derivative of 4x squared plus 3 is 8x. And then we just write b plus. Then we do then we just write a again. And then we do the derivative of b. And when you do the derivative of that one, that's where your chain rule comes in. So right here is where I have the derivative of the outside function, with that piece included, by the way. And then, oh, you know what? I forgot to include the derivative of the inside, I think, didn't I? No, I did. I forgot this was supposed to be over 5, so my bad. So this actually was supposed to be 20 over 5, because the derivative of the outside would put a 1/5 in the front. And then a derivative of the inside would be 20x to the third. And then when you divide the 20 by the 5, which I haven't done yet, you would have gotten a 4. So most simplified answer would have had a 4 right there. Okay? So that's chain rule with product rule. Okay? Let's go ahead and take a look at another one here. Chain rule with quotient rule. All right. So now we have two rules to do, right? But the question is, how do we know what to do first? Like, backing up here a little bit, how did I know to do the product rule first and then the chain rule? Well, it's whichever one is the biggest controlling factor in the problem. So as you can see, the chain only applies to this piece, right? But this whole thing is a product. So since the product is the bigger part, that's what you start with. And then the chain rule comes in after you start working through the product rule. Now let's take a look at this one here. The next slide is a little bit opposite from that. In this case, we have a quotient rule on the inside here, right? But it's a function inside of a power of -2. So it's a function within a function, which is a composite function, which is a chain rule. So in this case, the chain rule is the bigger rule. So we're going to start with the chain rule, and then we're going to do the quotient rule after that. So now let's say that I wrote it like this, though, instead. It's going to be a completely different problem. Don't write this, just watch. But let's say that we had this. Oops. Same exact problem. It's just that instead of having the whole thing being raised to the -2 power, I'm just letting that -2 be on the top now. Well, now the chain rule, the inside-outside function, that's only a part of the quotient. So now the chain rule is inside of a quotient. And so for this one, you would do quotient first, and then you would do chain rule. But for this one, since the quotient is the inside function, you're going to do the chain rule first, and then the quotient. Okay? So those are different situations. So anyway, no more babble about it. Let's just go ahead and get down to business. So since we're going to start with our chain rule first, we do the derivative of the outside multiplied by the derivative of the inside. So my inside function is this whole thing here, so I'll take a moment to go ahead and trace it all. That's my inside function. My outside function is the quantity being raised to the -2 there. So the derivative of the outside is going to be putting the power in the front and taking 1 away from the power, and then leaving the inside exactly the same. And that's the derivative of the outside. Oops. Now we're going to multiply that by the derivative of the inside. Now the inside is the quotient. So this is where I'm going to do the quotient rule. So now it's going to be the quotient rule, which is low d high. Remember the little rhyme I gave you? Low d high minus high d low. Draw a line and square below. It's that one. So low d high minus high d low. Draw a line and square below. And there you go. So that's as far as I'm going to take it. I'm not going to go any further than that. I mean, there are things that we could do to try to simplify this, but it's kind of like pointless. You're never going to be asked to do something like that on an AP test and actually simplify it all the way down. That's a terrible waste of time. But it's still a good problem to practice so that you get used to the idea of doing chain rules and quotient rules together and all that sort of stuff. So anyway, so keeping all that in mind, why don't you guys try one just like that. So notice that for this one, the quotient is an inside function again. And so it's going to be just like the one I did with you, which means you're going to start with chain rule first and then quotient rule afterwards, okay? So go ahead and pause the video here and write out your answer, and you'll see the solution when you're done. And there you go. So those are some examples of doing product rule and or quotient rule in tandem with the chain rule, okay? All right, let's take a look at another example here. This is what I'm going to call the chain rule twice. Okay? Now, before I start teaching this example, I want to talk to you about eggs. Yes, I said it. Eggs. So I'm going to draw you guys a picture of an egg here. Eggs are interesting because they have 3 shells to them. They have an outer shell, and then inside of there, they have like a yolk. Well, not a yolk, I'm sorry. They have like this white juice. I don't know what you call it. They call it the egg whites, don't they? All right, so I'm going to draw this, scribble this in here, but that's the egg whites, right? And then even inside of the egg whites, there's something else. There's the yolk, right? So there's like 3 layers to an egg. Well, in the same way, there's kind of like 3 layers to this problem, okay? Let me show you what I mean. We have the yolk. The inside, the part of this function that's deepest inside is this. This is the thing that's most nestled inside of the entire problem right there. That's the yolk. Notice that that thing is inside the parentheses, buried deep down inside the problem. Next we have the egg whites. The egg whites are around the yolk. Okay? And then after that we have the shell of the egg, which wraps around the egg whites. And so, chain rule twice, it's like having a function. It's having a function inside of a function, which is, you got it, inside of a function. a function inside of a function inside of a function. Okay? And so when that happens, you get to do the chain rule twice. Now before we start this actual problem, let me show you how this works. So we looked at problems like this yesterday, or last class I should say, but today we're looking at problems like this. We have a function inside of a function inside of a function. It's a 3-level function there. So here's how the chain rule works. You do the derivative of the shell. Don't change anything else. Just do the derivative of the shell multiplied by the derivative of the egg whites. Don't change the inside of the egg whites. Times the derivative of the yolk. So it's basically just taking the chain rule out to one extra level. Okay. So derivative of the shell, derivative of the egg white, derivative of the yolk, all times each other. Okay. So that's what we're looking at there. Let's go ahead and apply that to the problem on this page then. Okay, so let's start with the derivative of the shell, which I have colored in red here. So this is a power rule, okay? We have a quantity being raised to the third power. So I'm going to put a 3 here, parentheses, squared. And then we have our plus 1 in here. And then everything else inside of there is going to stay the same. You know, I just realized, though, guys, I think I miscolored this. This 1 here is actually part of the egg whites. My bad. I hope that makes things make a little bit more sense. Oops. So that 1 goes with the other green stuff in there. Okay, so there's that, and we don't change the inside, so we keep all that stuff inside there exactly the same. So there's my derivative of the shell. Now we do the derivative of the egg whites, the green part. Okay, so the green part has 2 parts to it. It has this, and it has this, okay? When you take the derivative of the 1, though, it just goes away because 1's a constant. So the 1 just goes away. So all we really care about is this part in the bigger part here. So the green part here is a quantity being raised to the 4th power. So I'm going to put a 4 in the front, and I'm going to take 1 off of the power, and we don't change the inside. So there's the derivative of the shell. So now I've got the derivative of the egg whites. So now we've got the derivative of the shell, the derivative of the egg whites, and what's last is the derivative of the yolk, okay? And that's this piece in here. So what's the derivative of that? Well, we do the power rule here. That's going to be negative 12x squared. And when you take the derivative of a constant, that negative 3 just goes away. Okay, so what we're going to be doing is putting all these little monomial coefficients here together. So we're going to do 3 times 4 is 12, times negative 12 is negative 144, and then the x squared here goes with that. And then the binomial sets will follow. So we have and there it is. So you just have to find your 3 layers and do the derivative of each layer separately and multiply them all together. and you're pretty well set after that. Okay, so here's a guided practice. So usually when I'm doing school normally, what that means is we have student practices, which is the ones that I do. Examples. We have examples, which are the ones that I do. We have student practices, which are the ones that I have my students do. Guided practice is kind of like I do it, but my students tell me what to do. So I'm going to go ahead and teach it like that, even though there's nobody here right now. And I want you guys to actually be answering these questions yourself as I ask you them. Okay? So the first thing I want you guys to do is I want you to tell me, what is the yoke of this problem? What is the innermost function? Hopefully you guys thought it was the 4x cubed minus 3. Okay, now my next question. What is the shell, the outermost part of this function? What is the shell? Because I think it's easy to know what the yolk is. I think it's easy to see what the shell is. And once you've found those two things, the egg whites, it's whatever's left over, basically. So what is the shell, the outermost function? Hopefully you are seeing that it is the cube root of everything. Anything that I haven't colored yet is the egg whites. It's the middle function, the one that's not the inner or the outer, but the middle part. So there you have it. So that's your inner, outer, and middle functions of this double chain or double composite function rule. All right. So let's begin. Now, in the past, we've been dealing with radicals in a certain way. What have we been doing with these radicals? We never left them as radicals. What did we do? We changed them, right? We changed them into powers. So, for instance, the cube root, we wrote it like this. Okay? Same thing with the square root. Now, square root's a little bit weird because you don't see numbers there. So just so you know, when there's no number here, that means it's a 2. Same thing here. You can think of this whole thing as having a power of 1 on it, if that helps you. So the square root of 4x cubed minus 3 is written in a power like this. The minus 4 can stay exactly as it is. And then we have the 4x cubed minus 3. So I want you guys to notice I haven't done any calculus yet. This is all just, it's the same function, I just rewrote it differently. We don't like radicals, so we just replaced the radicals with powers, right? Now we can begin the calculus part, which is the derivative. So at this point, what's the derivative of the shell? So pause the video here and give it a shot. And when you unpause the video, you'll see the derivative of the shell. Okay, and there's the derivative of the shell. I put the 1/3 in the front and subtracted 1 from the power of the shell. Now we're going to go ahead and move on. We're going to do the derivative of the egg whites. Oh, now my pen wants to do the right color. Okay. All right, go for it. Pause the video. See if you get the derivative of the egg whites. And that's what we get there. The derivative of the quantity to the 1/2 power, put the half in the front, take 1 away from the half, negative half. The derivative of 4 is 0, so that just goes away. And then, of course, we get to take the derivative of the yolk next, and that's pretty straightforward. We just take the derivative of the inside piece here, which is 12x squared. Why don't you guys go ahead and simplify it down as much as you can. Pause the video and see if you can get it simplified. There's the simplified answer there. 1/3 times a half is 1/6. And 1/6 of 12 is 2, and the x squared stays with there. I forgot this little prime, by the way, so make sure you include that, because at this point we have taken the derivative, so therefore we need to have that symbol there. So I thought I was on the guided practice. I think the slides changed on me, so I went ahead and ended up doing the student practice instead, but it doesn't matter. The guided practice is pretty similar. So why don't you guys go ahead and pause the video and try to do this whole problem here on your own from beginning to end. When you unpause it, you'll see the solution. Okay, there's my solution. I've got the shell, egg whites, and yolk color-coded there. I've got them in the first step. The second step, I've done the derivative of each piece separately. And then the last part, which is circled there, we have the simplified version of the answer. Okay? That might do it for our lesson. Let's see if there's any more. I'm not sure. No, that's it. So we're done with that lesson for today. And so we'll say, see you till next time.